on doing lot of problems. Yeah. You have to keep on doing lot of problems, including my homework problems. You have to see other problems which are there in your textbooks also. Okay, there are a lot of problems related with your matrices. You have 2 cross 3 and your 3 cross 3. That too, you have to know how to find out your characteristic equation. Okay, so for a 2 cross 2, what is your characteristic equation formula? For a 3 cross 3, what is your characteristic equation formula? You'll have to know. Okay, so that I will again go into the formulas and then we will go on to the next topic. Okay, so for a 2 cross 2 matrix, what was your formula? For your 2 cross 2 general formula, if you see, your general formula will be A minus lambda I is equal to 0. This will be your general formula. For your 2 cross 2 and for 3 cross 3 matrix, your general formula to find out your characteristic equation is model, that is your determinant of your A minus lambda I equal to 0. But when you use your formula is used so that you can do it in just a second. Okay, like that you can just do it in minutes. Okay, whereas here you have to find out, you have to write your A, then you have to find out your identity matrix. For a 2 cross 2 matrix means your identity matrix you will have to write according to your identity matrix for a 2 cross 2. Then you'll have to multiply with your lambda. Then you have to solve it, get your equation. Okay, whereas here directly you can use your formula. It is lambda squared. Cross 2 don't unmute yourself unnecessarily. Yeah, be very cautious of what you're doing. Don't unmute yourself unless and otherwise you're going to talk something related to the subject. Okay, because whatever has been done with you, it is directly going into my ears. Okay, very loudly I've kept so that I don't get disturbed with anything. Okay, so please don't unmute yourself unless and otherwise you're going to talk something related with the subject. Yes, yeah. So it is 2 cross 2 matrix. Since it is a 2 cross 2 matrix, immediately you start it with lambda square, then a minus. This is positive means next will be negative S1 lambda plus S2 equal to 0. Okay, this is your characteristic equation when it is a 2 cross 2 matrix. When it is a 3 cross 3 matrix, what is your formula? You started with lambda cube. Okay, you started with lambda cube minus S1. This is lambda cube means next will become lambda square plus S1 lambda minus S3 equal to 0. Okay, so this will be your formula for your 2 cross 2 and for 3 cross 3. You know what is your S1? S1 for both the terms, it is the sum of the main diagonal elements. Okay, it is the sum of the main diagonal elements. I don't know, for some people, when you've done your homework, you have multiplied it. Okay, be very careful. It is just the sum of the main diagonal elements. Okay, it will be the sum of the main diagonal elements, your S1, and your S2 for your 2 cross 2, it is the determinant of A. For your S3, for your 3 cross 3 matrix also, it is determinant of A. So for S2 and your S3, it is determinant of A. Here your S2 will be the sum of the minus of the main diagonal element. Okay, S2 is the sum of the minus of the main diagonal element. And many of you had gone wrong in your S3. Okay, S2 you have done it well. Okay, S2 determinant of A you are able to do, but when it comes to a 3 cross 3 matrix, you are going wrong. Do a lot of problems, then you will come to know how you have to do your determinant. Okay, so we will continue with your next topic. So this is your characteristic equation. Next, we will go on to naming theorem. Okay, that is a very, very important theorem. So that naming theorem is Cayley-Hamilton theorem. So what is today's date? Take your notebook, put today's date, and today's topic will be Cayley-Hamilton theorem. Cayley-Hamilton. For 2 marks definition, this Cayley-Hamilton theorem will be asked. A very, very important question. Cayley-Hamilton theorem. Very, very important. For your 2 marks question, always this Cayley-Hamilton theorem. You have to know the statement. Your Cayley-Hamilton theorem is every square matrix. Write it down. Every square matrix. Every square matrix satisfies its own satisfies its own characteristic equation. Satisfies its own characteristic equation. Okay. So according to this Cayley-Hamilton theorem, what is your statement? Every square matrix, okay, every square matrix satisfies its own characteristic equation. You are finding out your characteristic equation. No, that characteristic equation, when you solve it, it will be equal to 0. Okay, so it will always, every your square matrix will satisfy its own characteristic equation. That is your Cayley-Hamilton theorem. Okay. The same thing they can ask you in 16 marks also. They will give you a given matrix. They will give you a matrix and tell you to prove whether it is satisfying your Cayley-Hamilton theorem. If it is a square matrix, definitely it will satisfy your Cayley-Hamilton theorem. Okay. So every square matrix which satisfies its own characteristic equation is your Cayley-Hamilton theorem. Write it down. Theorem statement, very important. I will always ask you the statement, you'll have to tell me. You have to not change any of the words, it has to be the same. Okay, you have to say satisfies. Okay, every square matrix satisfies its own. Everybody, what they will write is, they will write square matrix, they will write characteristic equation. That too will be there, but other terms won't be there. You have to write satisfies its own characteristic equation, then only the theorem is satisfied. Okay, so your theorem statement is every square matrix satisfies its own characteristic equation. So this is your statements heading. We will go on to problems. Show that the matrix matrix is a 2 cross 2 matrix. 1 minus 2, 2, 1 satisfies its own characteristic. Satisfies its own characteristic equation. C is nothing but characteristic equation. Yeah, satisfies its own characteristic equation. So first what you'll have to do is, you will find out your characteristic equation. Find out your characteristic equation. This is a 2 cross 2 matrix. For a 2 cross 2 matrix, what is your formula for your characteristic equation? Write it down. So that will be lambda square minus S1 lambda plus S2 equal to 0. Okay. Immediately you will write your formula for your characteristic equation. What is your S1? Tell me your value of S1. Find out and tell.
2.
Very good. So your S1 is 2. Your S1 is 1 plus 1, which is 2. Then your S2, it is determinant of A. So 1 minus 2, 2, 1, multiply and 10.
5.
5. Very good. So your S2 is 5. That is 1 minus 4. Minus into minus, it will become plus. So it will become plus 4. So 1 plus 4, which is 5. Now your characteristic equation is lambda square minus S1 is 2 lambda plus 5 equal to 0. This is your characteristic equation. Okay, so till characteristic equation you already know. Okay, I think all of you would have gotten it. Now they have asked you have to show that this matrix satisfies its own characteristic equation. So you will have to prove. Okay, so how do you prove is whatever scalar you've got here, your lambda is your scalar. This lambda is your that scalar. You take it as A. Okay, the given matrix you will take. So when you take your lambda to be A, now what you'll have to prove is to prove. So instead of this lambda, you will take that lambda to be the given matrix. That is A square minus 2A plus, if you have got a constant term, that you will take it as the identity matrix. Okay, so here it is, there is no lambda, you have got a constant term. When you've got a constant term, you will multiply it with your identity matrix. So that will be 5i is equal to 0. So this is what you're going to prove. Okay, your Cayley-Hamilton theorem prove that you prove the given matrix satisfies your Cayley-Hamilton theorem. If they are asking it like that, what is it is, you'll find out your characteristic equation. After finding out your characteristic equation, you will substitute instead of lambda your given matrix, and if you've got a constant term, you will write it as your identity matrix. Okay, so you take this as your first equation. Okay, now from here, first we will find out what is your A square. So your A square is nothing but A dot A. You have to multiply the given matrix 2 times. Okay, so that will be 1 minus 2, 2, 1 into 1 minus 2, 2, 1. Okay, so that is your A dot A. When you multiply your A dot A, tell me what you get. You're multiplying A dot A, row and column. Okay, first row, first column, first row, second column. So when you multiply it like that, it will be 1 minus 4, and then first row, second column, it will be minus 2, minus 2. Second row, first column, 2 plus 2 minus 4 plus 1. Okay, I've just multiplied it. Okay, I'm multiplying 1 into 1, 1, minus 2 into 2, minus 4. 1 into minus 2, minus 2, minus 2 into 1 is minus 2. 2 into 1 is 2, 1 into 2 is 2. Okay, 2 into minus 2 is minus 4, 1 into 1 is, okay, with your addition, if you've got that subtraction, put subtraction. Now your final answer will be minus 3, minus 4, here it will be 4, and minus 3. So we have got your A square. Okay, that is your A square. Now we have found out A square. Next you have to find out 2A. Just writing this characteristic equation. Yes? So no. Have you all written your characteristic equation? I will take it that you have finished. Okay. So next we will find out your 2A. Your 2A is nothing but you're going to multiply 2 into this term. 1 minus 2, 2, 1. So your 2A will become 2 minus 4, 4 and 2. This is your 2A. Then we have to find out your 5i. 5i is nothing but 5 into I is for your identity matrix. So since it is a 2 cross 2 matrix, you will write 1, 0, 0, 1. So your values will be, you're multiplying 5 inside, it will be 5, 0, 0, 5. Okay. Now we have got your A square, we have got your 2A and your 5A. We will substitute all these values in your first equation. Okay. So we will substitute A square, 2A and 5I in your first equation. Okay. In your first equation, which is A square minus 2A plus 5I. which is equal to your A square value is minus 3, minus 4, 4, and minus 3. And then you've got minus 2a. So multiply with this 2a minus, and I put here plus. I'm multiplying it here with minus, so it will become minus 2 plus 4, minus 4, and minus 2. Then it is plus 5i. So plus 5i, we'll write 5, 0, 0, and 5. So for your addition, how do you do? If you take the first value, you will take the first value in all the columns, okay, all the rows. So minus 3, minus 2, 5. So that will be what? We'll write minus 3, minus 2, and plus 5. Then next one, minus 4, plus 4, and 0. You come down, plus 4, minus 4, and 0. And here you have minus 3, minus 2, and plus 5. Okay, so when you add it, here minus 3, minus 2 plus 5 will become 0. Minus 4 plus 4 will become 0. 4 minus 4 will become 0. Here also. Hence, the given matrix satisfies its own characteristic equation. You will conclude it. Okay, you will conclude it. Hence, the given matrix satisfies its own characteristic equation. Satisfies its own characteristic. Okay. You're able to see down. So you'll have to conclude. Hence, the given matrix satisfies its own characteristic equation. Any doubts? So the given problem, if they're giving a problem and asking you to prove your Cayley-Hamilton theorem, first step is to find out your characteristic equation. After finding out your characteristic equation, instead of lambda, you will take it as your given matrix. Okay, whatever notation you've got it in your question, accordingly write the notation. Okay, so instead of your lambda, you will write your given matrix, and after writing that given matrix, what you'll have to do? You'll have to find out the values. Here it is a square minus 2a plus 5i. You found out a square, then you found out 2a, then you found out 5i, then you substitute it in that first equation. See whether it is equal to 0. It will be equal to 0 if it is a square matrix. Okay, write it down. You finished? You finished writing? Tell me. This one, no. It's a very simple problem. 2 cross 2 matrix. Why are you taking so much time to finish? Can you write it little more fast? You all finished writing? Yeah? We'll go to a 3 cross 3 matrix. Have you all finished writing? Why are you not answering? Finished writing? you're able to hear. Okay, so I will go on to the next one. I want you to answer so that the problems will be done very easily and we can do more problems. Okay. If you be very quiet like this, I don't know whether I'm audible. You're all able to hear me or not. You're able to hear me? CSC
Yes,
1A.
ma'am.
Then why are you not answering? See, from 3 cross 3 matrix, your calculation will be very tough. I want you to answer so that I will do the problem easier. You can have your calculators and you can do with your calculators. Okay, take out your calculators. If you've got your calculators at home, please take your calculators so that we can do the problems which will move faster. Okay, so from 3 cross 3 matrix, it is going to become tougher. So you can use it using your calculators. So write your question. Verify Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem. Your Cayley-Hamilton theorem we represent like this. For the matrix, verify Cayley-Hamilton theorem for the matrix. I'm going to tell the 3 cross 3 matrix. Okay, so that 3 cross 3 matrix is 2 minus 1 1, 2 minus 1 1, minus 1 2, minus 1 1, minus 1 2. Okay, and also find A inverse. Also find A inverse. They have also asked you to find A inverse. First, we will prove your Cayley-Hamilton theorem. Then I will tell you how to find A inverse. Okay. So what you have to do? This is a 3 cross 3 matrix. So for a 3 cross 3 matrix, immediately write your formula for a 3 cross 3 matrix. So what is it? It is, tell me the
Lambda T
formula.
minus S1 lambda 2
Lambda, hmm,
S1
lambda
minus
square.
lambda 2 plus
Hmm, hmm.
S2 lambda minus S3 equals
Very
to
good.
0.
Okay. So this is your formula. Very good. Now find out what is your S1. S1 is your sum of the main diagonal. The sum of the main diagonal elements you're going to find out. So S1 is equal to,
2 plus 2 plus 2 equals to 6.
yeah, very good. So S1 is equal to 2 plus 2 plus 2, which is equal to 6. Your S2, it is the sum of the minus of the main diagonal. So I will write the minus, you find out. Okay, for 2, the minus are 2 minus 1 minus 1, 2 plus, you're going to write the minus, minus of the main diagonal. For this, it will be 2, 1, 1 and 2 plus, for this, it is 2 minus 1 minus 1, 2. Okay, this will be the minus of this matrix. So what you get? Okay. So what do you get? What is your S2? From here we are getting 3. Here also it is 3. Here also you get 3. So what is your S2?
9.
Very good. So we are getting your S2 to be 9. Next we have to find out your S3, which is determinant of A. Your determinant of A only many had gone wrong. Be very careful when you find out your determinant. So you will take this value 2 into, you multiply this 4 minus 1, which will become 3, minus into minus plus 1 into minus 2 plus 1. Minus 2 plus 1. So it will be minus 1 plus 1 into 1 minus 2 minus 2. So it will be 6 minus 1 minus 1. So your
4.
S3 is Okay, now you substitute your S1, S2, S3 in this equation. So it will become lambda cube minus your S1 is 6 lambda square, then minus, then it is plus 9 lambda, then you have minus S3. So minus 4 equal to 0. So this is your characteristic equation. Now in the question they have asked you verify Cayley-Hamilton theorem. So to verify Cayley-Hamilton theorem, what you will have to prove? You have to prove that your instead of lambda, you will take it as a cube minus 6a square plus 9a, and if you have got a constant, you will take it as your
4i.
identity matrix. Very good. So 4i is equal to 0. So this is you're going to prove. So to prove that problem, first you have to find out a square. You have to find out your a cube. Then you have to multiply it with 6a square, 9a. Then you have to multiply with your 4i also. Okay, so all those things you have to find out. We will start with a square. Okay, a square is nothing but a dot a. You have to multiply the given matrix 2 times. Concentrate and you will have to multiply. Otherwise, you will go wrong. Okay, 2 minus 1, 1. Minus 1, 2. Minus 1, 1. Minus 1, 2 minus 1, 1. Minus 1, 2. Minus 1, 1 minus 1. You're going to multiply this 2 times. So 2 minus 1, 1. Minus 1, 2. Minus 1, 1. Minus 1, 2. Multiply carefully. So first row, first column. Okay. So 4 plus 1 plus 1. Okay, next one, first row, second column. Minus 2, minus 2, minus 1. 2 plus 1 plus 2. Second row, first column. Minus 2, minus 2, minus 1. 1 plus 4 plus 1. Minus 1, minus 2, minus 2. Last row, first column. 2 plus 1 plus 2. Minus 1, minus 2, minus 2. Okay, minus 2. Yeah, last row, last column. Last row, last column. 1 plus 1 plus 4. When you're doing the problem, concentrate and do. You will not go wrong. Okay, I will rub this side. So after that, find out what is your a square. The a square, just you're adding. Okay, so it will be 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, and okay, so this is your a square. So in that given question, this first equation, no, this first equation, I want 6a square. Because this a square is already very big, we will find out that 6a square also. So that when you do the problem, when you substitute it there, it will be easier. Okay, so you have to multiply this matrix into 6. That is your 6a square. So your 6a square will become 36. 6 into 5 will become minus 30. 30 minus 30, 36 minus 30, 30 minus 30 and 36. So this is your 6a square. Okay. Next we have to find out your a cube. Okay. Your a cube you have to find out. Your a cube will be nothing but a square dot a. Okay. Whatever we have got, your a square we have got now. that into again your A matrix. So your A square is this term. Okay. So that is 6 minus 5, 5, minus 5, 6, minus 5, 5, minus 5, 6. This into your A matrix is 2, minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. Okay. So I've taken your A square and your A matrix. Now multiply it. Okay. Multiply it. Total be 12. First row, first column. 12 plus 5 plus 5. First row, second column will be minus 6, minus 10, minus 5. Okay. Minus 6, minus 10, and minus 5. Again, first row, third column. So it will be 6 plus 5 plus 10. Okay. Similarly, second row, first column. Minus 5 into 2 is minus 10, minus 6, minus 5. Second row, second column. 5 plus 12 plus 5. Second row, third column. Minus 5, minus 6, minus 10. Okay. Third row, first column, 10 plus 5 plus 6. Third row, second column, it will be minus 5, minus 10, minus 6. Third row, third column, 5 plus 5 plus 12. Okay. Be very careful when you're doing the multiplication. Okay. So after that, you add it. Have you all written that side? Find out your A cube. I will write it this way because here I've got space. So 12 plus 5 plus 12, that is 22. 22. This will be 10, 21, minus 21. And here it is 21. Here minus 21. 10, 22, minus 21. 21, minus 21. So this is your A cube. So this is your A cube which I found. Okay. So this is your A cube. So we have found out your A cube. We have found out your 6A square. Next you'll have to find out your 9A. Find out your 9A. Find out your 9A. We will rub it this side. So we will find out your 9A and 4I. Okay. So 9A is nothing but you will multiply 9 into your A matrix. Okay. So your A matrix is 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. So when you multiply it, you will have 18 minus 9, 9, minus 9, 18, minus 9, 9, minus 9, 18. This is your 9A. Then find out your 4I. 4I is nothing but, since it is a 3 cross 3 matrix, it will be 4 into 1, 0, 0, 0, 1, 0, 0, 0, 1. So when you multiply it, you will have 4, 0, 0, 0, 4, 0, 0, 0, 4. Okay, so 4i also we have written. After writing this 4i, what you have to do? You will have to substitute it in this first equation. Substitute everything in your first equation and check whether it is satisfied. Okay, that will be your homework. You substitute all the values. Okay, your 6a square minus 6a square around all these 6a square which you have found out, multiply it with your minus sign. Okay, everything will change your signs. Okay, you'll have to change the sign. And for your 4i also, for 4i also it is minus. So you'll change the sign and see whether it is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, it will be 0. It will satisfy its characteristic equation. Every square matrix satisfies its own characteristic equation. If it is not becoming 0, you have done somewhere calculation wrong. Okay, so check it and then you will get it. Already I've got your values for your 6a square. What is your a cube? What is your 9a? What is your 4i? Substitute it in the first equation and see whether it is equal to 0. Okay, now tell me your attendance. 1. Tell me your attendance. 1, 2, 2, 2 is not there. Okay, 3,
Present, ma'am.
4. Tell quickly. 4,
Ma'am, 2
absent.
present,
5,
ma'am.
2 is present. Okay. 4, 4 is absent. 5, 6.
Present, ma'am.
Okay. You're 6, Amma. What's
Yes,
your
ma'am.
number?
6, ma'am.
7. Okay.
7 present, ma'am.
7%. 8.